All right, so here are energy problems for apes. One of the first things I think we need to clarify is the difference between energy and power. Now, energy is a quantity, how much. So a joule is an amount of energy, a kilojoule is an amount of energy, a BTU is an amount of energy. Now, these two I know look a little weird, but a watt second and a kilowatt hour is an amount of energy. When you get your energy bill, they tell you how many kilowatt hours you've used. So it's a quantity. How much have you used? Power, on the other hand, is a rate. So how much is used over a given period of time. So here it's joules per second. So that's how much power is needed. Kilojoules per hour, BTUs per second, or BTUs per hour. Now it's just implied. So again, 1 watt is equal to 1 joule per second, so that is still a rate. A kilowatt is equal to 1 kilojoule per second. Again, that's still a rate, so how much over a given amount of time. And what's hard is that these don't show time, but these do. So again, try to think about, instead of time, think about amounts. What are we asking for? So I put these up here to kind of help you out. This is probably the most helpful one, where power times time gives you the amount of energy. So total energy used. And again, watts, like if I wanted to calculate how many watts, it's joules per second. Again, this gives me a rate. So again, this W doesn't stand for work, it stands for watts. So let's go down to our conversion table here. Now, this conversion table is really large, and the AP Environmental Science Test is going to give you the conversions that you need. So you just need to be comfortable with dimensional analysis. So here it's just some of the things we've talked about up above, like 1 joule is equal to 1 watt per second. 1 joule per second down over here is equal to 1 watt. So this is power and this is energy. So 1 kilojoule is equal to 1,000 joules, and I'm not going to go through the rest. I don't have to give you this all the time. Usually if you need something specific, I will give it to you. There's a couple of knowns that you should probably remember, and that's 1 joule is equal to 1 watt per second, or 1 joule per second is equal to 1 watt. Now the problem is sometimes they just put watts. They don't put the per second part. So you just, again, think about what they're asking for. If it's an amount, it's a joule, it's energy. If it's a rate, so how long, then it's asking about power. So right here it's asking how many BTUs will 20,000 joules produce. So I'm going to BTUs in joules, and again, if I'm looking here, joules to BTUs, it doesn't include time, so it's just energy to energy. And if I asked you to go from joules to kilojoules, or joules to watt second, or joules to kilowatt hour, you wouldn't really need time because you're going from energy to energy. Same thing with power. If I'm asking you to go from joules to watts or kilowatts to kilojoule hours, you don't really need time in there because you're only going from power to power. All right, so let's look at how we would do this. So we could start off with 20,000 watt hours here. Now, I don't want my answer to be in watt hours, so I need to cancel that out down over here. So these two you would cross off, but there is a conversion. So, okay, like what will give me something up here? So I'm coming back over here. So I can see, okay, 1 watt hour is equal to 3,600 watt seconds. And that's because there are that many seconds in an hour. So that's one of the other conversions you should probably know. But I still don't want my answer in watt seconds, so I need to get rid of this by cross-canceling out the watt seconds. So the watt seconds are down over here, and I need to look at a conversion that will switch it over to BTUs. And here I have it. 1,055 watt seconds is equal to 1 BTU. Once I have that, I can just plug in my numbers. If the numbers are across the top, it's multiplication. If there's numbers on the bottom, it's a division problem. And so what I've done is I've kind of pre-filled this out. So, your watt hours here are going to cancel out. So it's 20,000 times 3,600 divided by 1,055. Because, you can go, 3,600 divided by 1. Well, it's still going to give you the same answer. And this is basically 1 over 1,055. Could you do the inverse of this? Yes, if you're a mathy person, you can do it. If not, just divide by 1,055. All right, here's where things get a little weird. So I'm going to take this out for just a quick minute. It's asking how much energy in kilojoules does a 75 watt light bulb use when it is turned on for 1 hour? Now, when they say 75 watts or 100 watts or a 60 watt light bulb, really what they're saying is that it takes 75 watt hours, which is an amount of energy. So again, it takes 75 watt hours, okay, a quantity. So here's kilowatt hours, but you could also have watt hours. It takes 75 watt hours to run that light bulb for 1 hour. So assuming it's run for 1 hour, it's going to be 75 watt hours worth of energy. So all I want to do is I want to switch that over, because again, we're still in energy. Again, we're just in watt hours, okay, because it is an amount of energy, and change it over into kilojoules. So if I know, okay, how many watt seconds are in 1 watt hour? Well, I go back to, okay, how many seconds are in an hour? So that's a number you're going to kind of need to know after a while. 3,600. So in 1 watt hour, there are 3,600 watt seconds. Well, how many watt seconds are in a joule? So I'm going to come back over here. 1 watt second is equal to 1 joule. So 1 watt second is equal to 1 joule. And if you're asking, well, that's dumb. Why are you doing 1 over 1? Is this going to be 1? It's just to get you in the habit of canceling out units. Look, the watt hours are going to cancel out. The watt seconds are going to cancel out. But you still need to cancel out the joules. So here you need to figure out, okay, what's the conversion between joules and kilojoules? So I'm going to come back over here. I have the kilojoule compared to regular joules. So 1 kilojoule, or I could go 1,000 joules, is equal to 1 kilojoule. Now again, the 1 over, you take 75 times 3,600 times 1 over 1 is 1. And you're like, well, why do I need to do that? Again, just get used to canceling out units. It's going to get you out of a lot of trouble if you do that. And then that will get you your answer once you take it all the way across. Problem number 4. This one says the kilowatt hour is not a unit of power, but of energy. So the kilowatt by itself is a unit of power, and the hour is a unit of time. So again, power, kilowatt, times a unit of time is going to give you energy. So how much energy was used? So the kilowatt hour is equal to 1 kW, okay, which just means, again, that 3,600 seconds. So I want you to convert kilowatt hours to kilojoules. So again, I want to get rid of kilowatt hours. So how do you cancel that out? Well, I can change it into the watt hour. So kilo means 1,000. So there are 1,000. This is 1 kilowatt hour. So there's 1,000 watt hours in there. I want to get rid of the watt hour. Okay, so what's 1 watt hour? Sorry, this is N. 1 watt hour is equal to 3,600 watt seconds. How many joules are in 1 watt second? Well, there's 1 joule in 1 watt second. And again, I know some people are going to be like, well, why do I have to do this step? Again, it's just to get you in the habit of cross-canceling. Because if not, this is what gets people into trouble, is that they just start trying to plug numbers in and they don't pay attention to their units. If you do this, you're certain to end up with the right unit. Because here, now you're going to cross off joules. So there is 1,000 joules in 1 kilojoule, and that will get you your response. All right, before we go to the next problem, I just want you to notice, what did we do here? We went from kilowatt hour to kilojoules. And just referring back here, kilojoules to kilowatt hour, it's just energy to energy. There's really no need to convert or use time in any of that. So here's where we get to the part in red. Now we're going to go ahead and factor in time. So it's asking how much energy does a 75 watt light bulb use? Again, it's using 75 watts in an hour. If it's turned on for 30 minutes, so it's not turned on for an hour anymore. So you need to calculate this in 2 parts. I recommend that you always take care of the time part first. And I know some of you are saying, well, I know that 30 minutes is half of 1 hour. But they're not always going to give you 30 minutes. What happens if they give you 23 minutes? Okay, that is not easily done in your head, and you cannot use a calculator. So the best way to do this is take care of the minutes part first. So 30 minutes. You don't want it in minutes. You want to know how many hours this ran for. So the minutes cancel out, and then you have 60 minutes in 1 hour. So it's going to be 30 divided by 60. It's going to give you 0.5. And I know most of you could do that without the setup. But again, it's just making sure that you leave it in hours. And then you can have, it's a 75 watt bulb. So look, the 75 watt bulb runs for 1 hour. So how much energy does it use? Okay, so basically when I'm not going to put it here, when I combine this and this, it's going to turn into a 75 watt hour. Okay, but I'm going to take this out because this watt is going to cancel this out. This hour is going to cancel out that hour over there. But you don't want your answer in watt hours. Okay, you want your energy unit in kilojoules. This is also an energy unit, a watt hour. So you want to change it to watt seconds. How do I know it's 3,600 watt seconds? Well, there's 3,600 seconds in an hour. Okay, so watts stay the same, but the seconds have changed here. All right, how many joules are in 1 watt second? Well, there's 1 joule per 1 watt second. And then over here, how many joules are in a kilojoule? Well, there's 1,000 joules in 1 kilojoule. So this is taking time into account now, along with power. So when you have time and power, so this right here, this part right here is power, 75 watts, and time. That's how this turns into energy. So by the time you get here, you're now working in energy once these two are multiplied. So yes, you can do it like this, which is why I have it like this. 75 watts, okay, a unit of power times time gives you 34.5 watt hours, a unit of energy. And from here, it's energy to energy. Okay. So hopefully that helps you out in the first couple of problems.